Hey there, scientific audience. So now let's solve problem number 1.15. Here we are given uniform electric field which is along plus I. This vector is plus I cap. So that means the electric field is purely along x-axis. And so we can say that uniform electric field or lines are parallel. So these are the electric field lines and they are along positive x direction. And this electric field which is given to us is 3 into 10 raised to 3 Newton per Coulomb, right? Which means that if we put any positive charge, unit positive charge, it would experience this much amount of force. Now, what is the flux passing through a square of 10 centimeter side whose plane is parallel to YZ plane? So this is our x-axis, this is our y-axis, this is our z-axis. So basically this part, this square, right, let me call this as A, B, C, D. This square has length 10 centimeters and this length also is 10 centimeter, right guys? So the area of the square is 100 centimeters square. Now let me use some different color pen. Now we know the area vector. The area vector of this would be in this direction, depends on which side is the observer. So as per me, the area vector can also be in the backward direction, but we assume the eye or the observer to be over here. So that's why the area vector is always perpendicular to the plane and its magnitude is equal to the magnitude of the area. So area vector is basically having 100 centimeters square. It is the area, and you can even represent it as say 10 centimeter, and then you can say that 1 centimeter is equal to 10 centimeter square. So area vector is always perpendicular to the surface and it always represents the area of the surface, correct? Okay, so we know the flux passing through the area is equal to E dot A. So here it shall be equal to EA cos theta. Now you can see that electric field and area vector, they both are parallel, because since the square itself is aligned on xy plane, then any vector parallel to the xy plane will be parallel to the x-axis, right guys? So this vector A is parallel to the x-axis. So the angle between E and A is 0 degree. So electric field multiplied by area into cos 0, and we know that cos 0 degree is 1. So cos 0 would be basically 1. So let me write it once again, EA cos 0 degree. So here it will be electric field, which is already given, and we need to check that everything is in SI unit. So 3 into 10 raised to 3 multiplied by, since it is 100 centimeters square, so we need to convert that into meter square. So divided by 10,000 meter square, right? And these two zeros cancel. Again, these two zeros would be cancelled with the two zeros from the top. So our answer would be 30, and you can check by yourself that it is Newton meter square Coulomb raised to minus 1. Correct? Because Newton per Coulomb is the SI unit of electric field and area is meter square. So this is our answer, guys. Now this is the A part. Now in the B part, the same square is now little bit tilted. Suppose the square is bit tilted, so its area vector will also be tilted with respect to the positive x direction. So this is the positive x direction, guys. This is plus x-axis along which there is an electric field. Now you can just assume the square to rotate a bit and comes down, and area vector compulsorily should be perpendicular to the surface. And in this way, the angle between electric field and area vector is 60 degree. So if I calculate the flux now, it is EA cos 60 degree, and cos 60 is half, and EA value we have already found out, cos 60 is half. So our answer is 15 Newton meter square Coulomb raised to minus 1. So hopefully guys, you have understood the problem. This is our first answer and this is our second answer, guys.